So let's talk about what we're going to do here. So we have complex polynomials. A complex polynomial of degree n has this form. If n is 3, it's, x cubed plus something x squared and so on. And all the values here are complex numbers, but we don't mean that they have an imaginary part. The reason we say that they're complex numbers is because we can factor them. If we factor them into linear factors, then we can have complex zeros or complex roots. We will go over it all. The fundamental theorem of algebra says that every complex polynomial, as long as the degree is greater than or equal to 1, so the degree is always the largest exponent, so even if it's x plus 2, it has at least one complex zero. So say we had x plus 2, our zero would equal -2. Let's say we had x squared minus 4. We could factor that to x plus 2 times x minus 2, and we have two zeros. We have a 0 at 2 and at -2. Okay, so basically every complex polynomial of degree n greater than or equal 1 has at least one complex zero. Now let's talk about zeros of multiplicity. So we're going to talk about a few different things, and then we're going to put it together and learn how to graph a polynomial. So zeros of multiplicity. If P is a polynomial with degree n greater than or equal to 1, and x minus c is a factor. So for example, if I have x squared minus 4, I can factor that to x plus 2 times x minus 2, and I have two zeros. So x minus c is like an x plus 2 or an x minus 2. And they occur as a factor, but it can occur more than one time. It can occur n times. For example, if I have like x plus 2 squared, what that means is I have my c is equal to -2. That's what they're saying there. So I have a 0 of -2. And because I have, this is the same as x plus 2 times x plus 2, I have a multiplicity of 2 because I have two zeros at -2. Okay, so let's do this problem. Identify the multiplicity of a 0. Factor the given function completely, writing repeated factors in exponential form. Then state the multiplicity of each 0. So let's begin. So we have p of x. And the first thing I want to do is I want to factor x squared plus 8x plus 16. And I can say that's the same as x plus 4 squared. Okay, if you multiply that together, you'll get x squared plus 8x plus 16. Then I want to factor x squared minus x minus 20. And I can say that's the same as x minus 5 times x plus 4. And then I have this x minus 5. Okay, so now notice I have this polynomial. I've factored it in to multiple linear factors. So let's put them together. I have x plus 4 squared, x plus 4, which means I have x plus 4 to the third power. And then I have x minus 5 and x minus 5. So I have x minus 5 squared. Okay, so factor the given function completely. I did. Writing repeated factors in exponential form. I did. And then state the multiplicity of each 0. Well, here I have a 0 of -4, because -4 makes that 0, with a multiplicity of 3. Here I have a 0 of 5, because x minus 5 equals 0 means 5 gives me 0. And here I have a multiplicity of 2. So that's what I mean by factors. That's what I mean by zeros. And that's what I mean by multiplicities.